Hello students, welcome to Lagrange's mean value theorem and its problems. Let's get started. So discuss the applicability of Lagrange's mean value theorem for the following functions. Let's take the problem. The first question is, suppose I have a function f of x equal to rational function 1 by x over the interval close minus 2 to plus 2. Okay, you can compare this interval with a to b. So we need to check this function satisfies two conditions of Lagrange's mean value theorem or not. Okay, so afterwards we will decide the nature of the given function. Here the given function is a rational function over the interval minus 2 to plus 2. Here, so let's start it. So since the very first condition is we need to check continuity over the interval close minus 2 to plus 2. So since we can say clearly by the inspection limit x is tending to 0. Why I am taking 0 means this given interval includes minus 2 to plus 2, which includes 0 here. Okay, there are many points. So okay, among those points I am taking here 0. So I am going to find the limit of the function at x is tending to 0. Limit of the function at x equal to 0, which means the limit x is tending to 0 f of x. So which gives limit x is tending to 0, f of x means 1 by x. So if you plug in x equal to 0, you will get 1 by 0, which means you will get infinity. Okay, limit is does not exist. We can say here, so limit is does not exist. Does not exist. Limit is infinite means it does not exist limit. So the answer is, since if you plug in x is 0, 1 by 0 means infinity, which means infinity means limit is does not exist. Means function is not continuous at the point x equal to 0, meaning, okay, we can say here f of x is not continuous, f of x is not continuous at x equal to 0, but we need to generalize over the interval close minus 2 to plus 2, which means, how do you say? So therefore we can say here f of x is not continuous, f of x is not continuous on closed interval minus 2 to plus 2. It is not continuous at x, okay, over the interval minus 2 to plus 2. So hence first condition of Lagrange's mean value theorem is not satisfied. We can say Rolle's theorem is not applicable for the given function over the interval minus 2 to plus 2. Therefore, so we can say here, or hence Lagrange's mean value theorem is not applicable. We can say here Lagrange's mean value theorem is not applicable. Finish. That's your answer. Now let's take the new question. Another question. So I have the function f of x equal to log of 1 plus, or simply we can say here log x over the interval close 1 comma e. 1 comma e. The beginning value is e, the ending value is e. Okay. Now we need to check the conditions of Lagrange's mean value theorem here. So the first condition is, we can say here, so I can say f of x is clearly by the inspection, f of x is continuous here. F of x is continuous on closed interval 1 comma e. The reason is f of x is continuous on its domain. So here, because log x is a, okay, logarithmic function is, we know that continuous on its domain. So domain of the logarithmic function is open interval 0 to infinity. Okay, so which includes here, so this interval, given interval is having 1 to e, it does not include 0 also. Okay, so we cannot get here infinity chance. So that's the reason we can say 1 to e means, so here 1 after, so we will have more real numbers. E value is 2.7182 approximately. In between you can choose any value and to plug in okay, x, so in the given function we can say, so you will not get infinity, which means function is continuous everywhere over the interval 1 comma e. Okay, so the second condition we'll check it. The second condition, differentiability, we need to check. Since we have f of x equal to log x, so then or implies Derivative of f of x is f dash of x. This is equal to log x derivative 1 by x. Here we can say f dash of x is exist for, we can say here, x belongs to open interval 1 comma e. Just I'll be writing here, this is the interval 1 to e. Okay, the e value is approximately 2.7182, so on. It's a irrational number. Okay, in between here there is no zero at all. Okay, if there is a zero, so if you plug in denominator, 1 by 0 becomes infinity. So here we can say f dash of x is exist for x belongs to open interval 1 comma e, or for all x belongs to open interval 1 comma e. After that we can, okay, here two conditions of Lagrange's mean value theorem are satisfied. So we can say here all conditions of LMBT are satisfied. So by Lagrange's mean value theorem, the statement I am writing, there exists at least, you will get minimum at least one real number, one real number, let us say C, okay, belongs to open interval 1 comma e. We need to search at least one real number in the open interval 1 comma e, such that how do you find means f dash of C, which is equal to, this is the statement of Lagrange's mean value theorem, f of b minus f of a. So actual rule is, I'll be writing here f of b minus f of a, which is divided by b minus a. What is a and b? Actual interval is, so 1 comma a. Let us suppose here, this is, you can compare with a comma b. A means 1, b means e. Now the next step is f dash of c. What is f dash of c? We have already here f dash of x. So in this f dash of x, so just plug in x equal to c. Here f dash of c becomes 1 by c. So the left side will become now 1 by c. So 1 by c, which is equals to right side f of b. B means e minus a means 1 divided by b minus a, which means e minus 1. So 1 by c equal to, so we have f of e. Since we have f of x, the function is log x, actual function is log x. F of e means plug in x equal to e, which means log e. So here numerator is log e minus f of 1 means if you plug in x equal to 1, log 1 by e minus 1. So 1 by c will become now log e value is, so it is, you can keep as, so log e to the base is, it's 1. So otherwise what I will do, I'll keep as log e here. This is log e to the base is 1, directly we can write, minus log 1 value is 0 divided by e minus 1, or else since we know the values of log e to the base e is 1, because same value with same base is 1, log 1 to the base e is here 0. So finally our c is c equal to, afterwards I can write the simplified form is e minus 1, 1 by c equal to e minus 1. So c equal to, if you cross multiply, e minus 1. So e minus 1, we can say this is clearly belongs to open interval 1 comma e. The reason is here we have 1, so end value is b, so we are not, okay, excluding 1 comma e as per open interval. E minus 1 means somewhere here e value 2.71 something, so e minus 1 means 1.718 something. This value is belongs to open interval 1 comma e. Okay, hence we can say Lagrange's mean value theorem is here verified also. Verified. Finish. Next we will discuss one problem, students. So the third question is, using Lagrange's mean value theorem, prove that 1 minus a by b, which is less than log of b by a, again less than b by a minus 1, where the condition is given as 0 less than a less than b. This is the condition given. Now proof. we will go for like this. Here, if you look the given problem, so we need to prove that 1 minus 1 by a less than log of b by a less than b by a minus 1. So with this condition, 0 less than a less than b, it represents a interval. Okay, fine. So what is the function to apply Lagrange's mean value theorem? We need a function as well as interval. So interval we can choose from here. A function okay. So by the inspection we need to choose here. He has not given directly function. So the function is log term is there here. So let us take log of some x. The function we need to choose from our side. So let f of x equal to log x. Now interval you can choose as a to b. Interval is a to b, because he has given here. So a is more than 0 and less than b. Let us take here interval is a to b, and one should remember here the domain of the logarithmic function is open interval 0 to infinity, which means excluding 0. So that's the reason here don't start from 0, start from a to b. Okay, now the here, so a value is more than 0. You can remember as per the given inequality. So a value is more than 0 here. So we can say the first condition we need to check continuity. Clearly we can say f of x is continuous. F of x is continuous on closed interval a comma b. The reason is, so logarithmic function is continuous on its domain. Domain is 0 to infinity. Here in this interval 0 is not included, so which means for every x, okay, you will not, if you plug in over here, so you will not get infinity. So it is a continuous function. So from the interval in the interval a to b. After that, differentiability, since we have f of x equal to logarithmic x, log x. Now differentiate this function with respect to x. F dash of x equal to 1 by x. Okay, we can say clearly f dash of x is exist for x belongs to open interval a comma b. So what does it mean? So here I have a, so again b, excluding a and b. So anyhow this interval does not include 0. There is no chance for getting here 0. If there is a chance, I will plug in here again. 1 by 0 becomes infinity. Okay, this interval does not include 0. So which means, okay, for every x you can, okay, take from this interval and plug in here, you will not get infinity. You will get a non-zero value always. Okay, that's the reason we can say here f dash of x is exist for x belongs to open interval a comma b. Two conditions of Lagrange's mean value theorem are satisfied. We can say here two conditions are all conditions. All conditions of Lagrange's mean value theorem are satisfied. Are satisfied. So by Lagrange's mean value theorem, Lagrange's mean value, so there exists at least one real number. One real number. There exists at least one real number. Let us say C belongs to open interval a comma b, such that, because our interval is a comma b, such that f dash of c, which is equal to, rule is f of b minus f of a divided by b minus a. This time a means a only, b means b only. F dash of c, means, so we have already f dash of x is 1 by x. So f dash of c means, so right side function will become now 1 by c. We can say here 1 by c. So which is equal to f of b means log b. F of a means log a, because f of x is a logarithmic function. So that's the reason f of b means log b minus f of a means log a divided by. So we have b minus divided by b minus a. The next step is, so 1 by c, which is equal to, we can say here log m minus log n numerator log m by n. So which means b by a divided by b minus a. Since we have a logarithmic rule, basic rule, so log m minus log n equal to log m by n. Now after that, let us suppose this is equation number 1. We cannot okay, get the direct result which he is asking, this one. So because the C is asking in terms of inequality, less than, less than. So to prove this result, again we have to be use our the condition. The condition means we have already mentioned here C belongs to open interval a comma b as per proof, as per this statement. Okay. The next step, since we have C belongs to open interval a comma b, we are searching a value C in the interval open interval a comma b. This, what does it mean of C belongs to open interval a comma b? This could be writing like this: A is less than C, less than b. The meaning is same. C is so between a comma b. So between a comma b. That's the reason. So A less than C, less than b. This one is representing like this interval. Is this interval I am representing in terms of inequality. Okay. After that, I need to substitute from equation 1 by C, 1 by C, but here I have only C is there, so I will take reciprocal. Reciprocal means 1 by A. So if you change, okay, if you take the reciprocal, the inequality sign will change. This will become greater than. So similarly, this is 1 by C, again greater than 1 by B. Take the reciprocal for each term. So change the inequality. So this is the simple idea. So we have here 5 is, so simple example, 5 is less than 6. 6 is less than, for example, 7. So this is same as we can say here. So 7 is more than 6. 6 is more than 5. This way. So I change it here. After that, 1 by A, which is more than 1 by C. 1 by C from equation 1, log B by A minus B minus A. So substitute here log of B by A divided by B minus A, and then which is more than, so 1 by B. After that, so as per proof, we need here middle term only log B by log of B by A. So don't have B denominator. So for that what we do, so we will remove denominator B minus A by multiplying. So multiply both, okay, for the inequality with B minus A, which means multiply B minus A. So for, okay, first term as middle term as well as last term. So when you multiply with B minus A, so here, so this could become B minus A by A, which is more than, here B minus A gets cancelled out, only you left with log of B by A, again which is more than, here B minus A divided by B. Okay, but we need to prove the result in terms of less than inequality. But okay, right now we have greater than inequality. So for that, what to do? Again recall this rule. Okay, so we have, for example, so 7 is greater than, okay, for example 6 is greater than 5, previous example only. This is same as, you can say like this also, 5 less than 6 less than 7. Change this term right as a first term. Okay, so B minus A divided by B, which is less than, I have to be right, this middle term becomes same, so again this will become less than B minus A divided by A. After that, divide. So here, so B by B 1 minus, so when you divide B by B, so you will get 1 here, which means, so 1 minus A by B, so again less than, this could be same B by A, again less than, here B by A, this will be B by A again, so I will be writing second term is minus A by A is 1, hence the result, we can say, hence the result. This is proved now. This is what he is asking to prove. Okay, let's take new question. Using Lagrange's mean value theorem, Lagrange's mean value theorem, prove that x plus 1 plus, we can say, or x plus 1 plus x less than e to the power of x, again less than 1 plus e power x, as given for x is greater than 0. This condition is given. To prove this result, so we will follow like this. Proof. Okay, so clearly saying using Lagrange's mean value theorem. So we need to prove this inequality. Again, function is not directly given. Interval also directly not given. So we know that exponential function is everywhere continuous. That's not a problem. Interval. So let us take here. So this interval is function is e power x by the inspection. So we will choose the function is f of x equal to e power x. Now interval you can choose. So interval is, let us choose the interval is 0 to, I can say x. You can choose randomly. X is here more than 0. Here x is, as per the given problem, x is not 0, it is more than 0, other than 0. Let us choose here 0 to x interval. Okay. After that, so we will check the continuity. So directly we can say f of x is continuous. F of x is continuous on close interval 0 comma x, because exponential function it is continuous everywhere. Okay, so on the given interval 0 to x also it will be continuous. Now second condition is, since we have function of x is e to the power of x, so we need to perform derivative. F of x derivative f dash of x, right side function e power x derivative e power x. So we can say here f dash of x is exist for x belongs to, we can say here x belongs to, we can say x is belongs to open interval, so 0 comma x, 0 comma x. So we can choose any x from this interval, the function is, it is exist. Now we can, that means f of x is differentiable, f of x is differentiable on open interval 0 comma x. Two conditions of Lagrange's mean value theorem are satisfied, we can say here. So all conditions, same procedure, all conditions of LMVT are satisfied. So by Lagrange's mean value theorem, again there exists at least one real number, one real number, let us say C belongs to open interval 0 comma x, such that f dash of x equal to f of b minus f of a divided by b minus a. So since we have interval is close 0 to x, you can compare with a to b, a equal to 0, b equal to x. The next step, f dash of x. So previous page, what is f dash of x? E power x. If you plug in x equal to c, you will get here. So f dash of x means e to the power of c, which is equal to, now right side f of b. Since we have f of x is e to the power of x, actual function. So f of b means, x. So a means 0. So I will be writing here b means x, f of x minus f of 0, which is divided by x minus 0. The next step, e power c equal to, now f of x means directly given function e power x, f of 0 means e power 0 divided by x. Now simplifying this function, e to the power of c equal to e power x minus 1 by x. So let us mark 1, since we know that e power 0 value 1. Okay students, but we need to prove in terms of inequality. Again we need to recall this one again. So the next step is, so I will take the new page. Let us recall, since we have C belongs to, we already specified C belongs to open interval 0 comma x. Now this is interval. Now change this interval into inequality. How do you write inequality representation? 0 less than C less than, this is less than, this is C. 0 less than C, okay, less than x. This could be writing like this. But I have from equation 1, I want e power c. E power c value I want. For that, what we do here, we can raise the power is e. Okay, base is e, which means e power 0 value we will find here. So if you apply e to the power of 0, check the e. So apply the basis e for each term. So e power 0, again e power c, again e power x. Now as we know that e power 0 is 1 less than e power c from equation 1. What is from equation 1? E power c e power x minus 1 by x. So I will be replacing here e power x minus 1 by x less than e power x. Since equation 1 I okay, so used here. After that, from denominator remove x. How do you remove? Multiply by x for the inequality. Multiply by x, which means here x is coming, x times 1x less than. Here x will cancel out, only left over with e power x minus 1 less than. For this term, if you multiply by x, you will get x times e power x. After that, this minus 1, you can transpose both side, or else you can add, okay, 1, you can add plus 1 for the inequality, which means 1 plus x less than, here e power x minus 1 plus 1, so less than 1 plus x times e to the power of x, which gives 1 plus x less than e power x less than 1 plus x times e power x, because opposite signs plus 1 minus 1 cancel out. So this completes the proof, hence the result. Hence the result. Thank you students for watching.